Imagine a world where buildings and bridges could heal themselves, automatically repairing cracks and damages the way human skin recovers from cuts. This isn't a scene from a science fiction movie. It's happening right now, thanks to self-healing concrete. Hi, welcome back to our channel. Today we're diving deep into the cutting-edge technology of self-healing concrete and how it's revolutionizing sustainable construction. If you're passionate about futuristic tech and how it can make our world a better place, hit that subscribe button, give this video a thumbs up, and click the notification bell so you never miss an update. And as always, let us know your thoughts and questions in the comments below. We love hearing from you. Self-healing concrete is an extraordinary material designed to automatically repair its own cracks, significantly extending the lifespan of structures and reducing the need for costly and resource-intensive repairs. This innovation is not just a step forward in material science. It represents a fundamental shift in the way we think about construction and sustainability. Concrete is the most widely used construction material in the world, but it's also a major source of carbon dioxide emissions, accounting for about 8% of global emissions. Traditional concrete, while strong, is prone to cracking, and these cracks can lead to costly repairs and shorter lifespans for buildings and infrastructure. Enter self-healing concrete, a solution that not only addresses the durability issues, but also contributes to environmental sustainability. The concept of self-healing concrete relies on the inclusion of autonomous healing agents within the concrete mix. These agents can be microcapsules filled with a healing agent, bacteria that produce limestone, or shape memory polymers that can close cracks. When a crack forms, these agents are activated and work to seal the crack, effectively healing the concrete. One of the most promising approaches involves the use of bacteria. Researchers have discovered certain types of bacteria that can survive in the harsh, alkaline environment of concrete. These bacteria are dormant in the concrete mix, but become active when a crack forms and water seeps in. The bacteria then produce limestone, which fills and seals the crack. This method not only repairs the concrete, but also improves its overall durability and strength. Another approach involves using microcapsules filled with healing agents like epoxy or other resins. These microcapsules are mixed into the concrete and remain intact until a crack triggers their release. The healing agent then flows into the crack, hardens, and seals it. This method has shown great promise in lab tests and is now being tested in real-world applications. Shape memory polymers are another fascinating technology being explored for self-healing concrete. These polymers can change shape in response to external stimuli like temperature changes or mechanical stress. When a crack forms, the polymer can contract and close the crack, effectively healing the concrete. This method is still in the experimental stage, but it holds great potential for future applications. The potential benefits of self-healing concrete are vast. For one, it can significantly extend the lifespan of structures, reducing the need for repairs and maintenance. This leads to substantial cost savings over the life of a building or infrastructure project. Moreover, by reducing the frequency and extent of repairs, self-healing concrete can also decrease the demand for new concrete production, thereby lowering carbon dioxide emissions and contributing to environmental sustainability. Additionally, self-healing concrete can enhance the safety and reliability of critical infrastructure like bridges, tunnels, and dams. By automatically repairing small cracks before they grow into larger, more dangerous fissures, this technology can prevent catastrophic failures and improve overall structural integrity. For example, in earthquake-prone areas, self-healing concrete can offer an added layer of protection by quickly addressing cracks caused by seismic activity. Now, let's delve into some real-world examples and case studies that highlight the impact of self-healing concrete in sustainable construction. One notable example is the work being done by Delft University of Technology in the Netherlands. Researchers at Delft have been pioneers in developing bacterial self-healing concrete. They have tested this technology in various projects, including a parking garage and a lifeguard tower. The results have been promising, showing that the bacteria can effectively heal cracks and enhance the durability of the structures. Another exciting project is the Hendrik Ido Ambacht Bridge in the Netherlands, which used self-healing concrete in its construction. The bridge, completed in 2018, incorporates microcapsules filled with a healing agent. When cracks form, the microcapsules release the agent, which then seals the cracks. This project has demonstrated the practical application of self-healing concrete and its potential to improve the longevity and sustainability of infrastructure. In the United States, researchers at the University of Michigan have developed a self-healing concrete using a combination of microfibers and a special type of cement. This concrete can heal cracks within 24 hours of forming, thanks to the microfibers that help distribute the stress and the cement that reacts with water to form a hard, crack-sealing compound. This technology has been tested in various applications, including sidewalks and bridge decks, showing significant improvements in durability and lifespan. The University of Cambridge in the United Kingdom has also been at the forefront of self-healing concrete research. Their work focuses on using shape memory polymers to create a concrete that can heal itself multiple times. This technology is still in the experimental stage, but early results are promising, indicating that it could be a viable solution for future construction projects. These examples illustrate the tremendous potential of self-healing concrete to transform the construction industry. However, there are still challenges to overcome before this technology can be widely adopted. One of the main challenges is cost. Self-healing concrete is currently more expensive to produce than traditional concrete, primarily due to the cost of the healing agents and the complexity of the production process. As research continues and the technology matures, it is expected that costs will come down, making self-healing concrete more accessible for mainstream construction projects. Another challenge is testing and certification. Self-healing concrete must undergo rigorous testing to ensure it meets the necessary standards for strength, durability, and safety. This process can be time-consuming and expensive, but it is crucial to ensure that the technology performs as expected in real-world conditions. Despite these challenges, the future looks bright for self-healing concrete. Advances in material science, biotechnology, and nanotechnology are driving innovation and bringing us closer to a world where buildings and infrastructure can repair themselves. This technology has the potential to revolutionize construction, making it more sustainable, cost-effective, and resilient. Before we wrap up, let's consider the broader implications of self-healing concrete for sustainable construction. The construction industry is one of the largest consumers of natural resources and a significant contributor to greenhouse gas emission. By extending the lifespan of buildings and infrastructure, self-healing concrete can help reduce the demand for new construction materials and lower the industry's environmental impact. Moreover, self-healing concrete aligns with the principles of the circular economy, which emphasizes the importance of designing products and materials that can be reused, repaired, and recycled. By creating structures that can heal themselves, we are moving towards a more sustainable and resilient built environment. In conclusion, self-healing concrete represents a groundbreaking advancement in the field of sustainable construction. By harnessing the power of biotechnology and advanced materials, we can create buildings and infrastructure that are more durable, cost-effective, and environmentally friendly. This technology holds the promise of a future where our built environment is not only resilient, but also regenerative. Thank you for joining us on this journey into the world of self-healing concrete. If you found this video informative and inspiring, don't forget to subscribe to our channel, like this video, and hit the notification bell so you never miss an update. And remember, we love hearing from you, so share your thoughts and questions in the comments below. Together, let's build a sustainable future with the power of innovative technology.